All right, so here we're going to talk about 7.2, and 7.2 now still uses the same concept of similarity. That's the whole concept of this unit. But now they're talking about similar polygons, so they're going to start to use it in reference to shapes. So first of all, getting some vocabulary down. Two polygons are similar if the corresponding angles are congruent and the corresponding side lengths are proportional. So that means the two shapes don't have to be necessarily the same size, but they have to be proportionately bigger or smaller than one another. And so it says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So if you take a look at the example number 1, it tells you that the polygon JKLM is similar. That's the symbol right there. That little squiggly means similar to WXYZ. And they first want you to list all the congruent angles. So let me just draw these out here a little bit. So the first one looks kind of like this, where we have JKLM. And then they have one that's a little bit smaller, but looks to be about the same shape, WXYZ. And it says list all the pairs of congruent angles. So again, it tells you that JKLM is similar to WXYZ. So that there is your similarity statement. So just like in the triangles, the similarity statement has to be written in a certain way. It has to be written that these have to correspond to these in order. So therefore, you know that angle J, this one here, has to be similar to angle W, or has to be even congruent, because if they're similar, they're actually going to be congruent. So they're going to be congruent to angle W. You don't even really have to look at the pictures to know that. You only have to look at the similarity statement. You know that angle K is congruent to angle X. You know that angle L is congruent to angle Y. And you know that angle M is congruent to angle Z. So now you've listed all the pair of congruent angles. The next thing it asks you to do is write a ratio of the corresponding sides. So that's exactly like what we did with the triangles, except it's just having one more letter with it. So I know the first two, JK, have to be similar to these first two, WX. That ratio has to be equal to the next two, KL and XY. And that has to be equal to the last two, LM over YZ. And that has to be equal to the first and the last, JM, all over the first and the last, YZ. So this is exactly what we did with the triangles. We just have 4 letters now instead of 3. The next thing it asks you to do on this here is to check that the ratio of the corresponding sides are equal. So these two quadrilaterals are only going to be similar if all of these 3 ratios are the same. So let's write in what they told us. They told us this was 4, this was 12, this was 16, this was 8, this was 3, 9, 12, and 6. So let's write in, based on our ratios, let's fill in all this information. So JK, if we find JK, right here is JK, that's 4. WX is 3. KL is 16. XY is 12. LM is 8. YZ is 6. And JM is 12. And WZ is 9. Now, in order for these two to be similar, each one of these ratios have to be equal. Well, it's hard to tell if they're equal now. We have to reduce them all to find out. So 4/3 is already reduced. Well, 16 over 12, I can divide both the top and the bottom by 4. So 16 divided by 4 will give me 4. 12 divided by 4 will give me 3. So those two are the same. 8 and 6, well, I can divide them both by 2. So 8 divided by 2 is 4. 6 divided by 2 would be 3. Well, all three of those are now the same. Let's see if the last one is. Well, 12 and 9, I can divide them both by 3. 12 divided by 3 will give me 4, and 9 divided by 3 will give me 3. Again, you could actually put each one of those ratios in your calculator and let your calculator do the work to reduce them for you if you prefer. So now you see that the ratios are all 4:3, which means yes, because they're all equal, then they are going to be similar. If just one of these wasn't equal, if just one of these, for instance, happened to be a 5, only one of them has to not be equal for the whole thing to not be similar. All right. But because all 4 of them are the same, then yes, these are similar. All right. So if we take a look at the second page, so let me see, let's go back here. So then they have 2 examples here. See if you can try example 1 and example 2. Let me know if you have questions on those. Here it says, determine whether the polygons are similar. So again, this is you're going to do on this one exactly what we did. You're going to first write out your similarity statement. Then you're going to write down your proportionalities. You're going to write all of these down, put the sides in, and see if they all equal each other. So see if you can do that for number 3. And on number example 3 here, they actually now are going to use the information to solve for x. So I'm going to do this one out with you. So on this example, they say they have 2 polygons. Let me draw them out again a little bit here. We have J, K, L, M, and a little bit of a bigger one where this is P, Q, R, S. And they tell me this is X, this is 12, this is 3, this is 12, this is 21, 28, 28, and 7. All right, and they tell you that J, K, L, M is similar to P, Q, R, S. So now that they tell me that they are similar, let's use this similarity statement to write up our ratios. So we know that JK is similar to PQ. We know that KL is similar to QR. LM would be similar to RS. And the first and the last JM would be similar to the first and the last PS. Now that we have those written in, let's go ahead and fill in the information that they gave us. So JK is X. PQ is 21. KL is 12. QR is 28. LM is 3. RS is 7. JM is 12. And PS is 28. Well, we know because they're similar, each one of these ratios has to be the same thing. So 3/7 is already simplified. These two are already the same. So let's see if we can simplify these two. Well, if I divide the top and the bottom by 4, 12 divided by 4 will give me 3. 28 divided by 4 will give me 7. So each one of these will equal 3/7. So I know that x over 21 also has to equal 3/7. So I can now use this relationship to solve for the problem. So once again, I have one ratio equal to another ratio. I can solve this by cross multiplying. 21 times 3 will give me, well, here, if you're not sure, grab your calculator, right? 21 times, oops, make sure you can see it, times 3, that's going to be 63. And you're going to multiply these two together. 7 times x will give you 7x. In order to get x alone, you're going to divide both sides by 7. We'll cross out here. If you don't know off the top of your head what 63 divided by 7 is, go ahead and grab your calculator. 63 divided by 7 will give you 9. So now you have solved for x. So here they have some problems on the bottom. See if you can try those. And then on the next page, they have a worksheet. So work through that. And if you have questions, please let me know.